Hey, it's Random Code here, and today we're going to continue with Advent of Code, and we are now at day 11, which is one of the easier days, once again. In this case, we simply have a universe with some galaxies, and we then need to find all the differences between the galaxies without any duplicates, and then simply sum them together. And what should become obvious quite fast is because we're simply finding the distance between these galaxies, and we're doing it like in a grid-wise search, more or less, that this distance is actually the Manhattan distance. And if you don't know the Manhattan distance when having 2 points, is simply the distance is the blue on this graph, showing the distance between 2 points following a grid. Where often we would use the Euclidean distance, which is the green line, just simply meaning the shortest path between 2 points. And then because we're just using the Manhattan distance, what we can simply do is find the coordinates of our 2 galaxies and calculate it. Quite simple. However, there's also an extra tricky part about today's exercise, which is that if we have a diagonally or horizontal line in this universe without any galaxies, it's going to be expanding, when the first task is just going to be doubling. So this empty line is going to be 2 empty lines, horizontally and the same vertically. So there's kind of 2 parts. First, expand the universe, find the position of the galaxies in the expanded universe, and then simply calculate the Manhattan distance. So in part 1, I'm doing a bit extra than actually needed, because when expanding my universes, I'm first finding all the indexes of expand by x and by y. I'm then actually expanding it by actually inserting new dots. I'm creating like a virtual map where I simply add horizontal and vertical lines to simply make the map bigger. From this bigger expanded map, so I first read my lines, I then expand my universe. I then extract my galaxy points, just simply going through all the points and find where is a galaxy. I'll then simply have my galaxy distance sum. I'm then just going to go through all my galaxies using 2 for loops and then comparing them one to another, going from I of 0 to the size of galaxies, and then from I plus 1 to size of galaxy to not have any duplicates, so only looking at the galaxy compared once. And that is basically the solution to day 1. And we can see it runs. It takes about 0.03 seconds, which I thought would be slower compared to the other kind of obvious solution, is that instead of actually drawing or creating this virtual galaxy map, we could just simply add these expand points to our coordinates and do it that way. And that is very much what's actually needed in part 2, because part 2 is the exact same exercise, but where part 1 only expanded by 1 on each dimension, both horizontally and vertically, part 2 now expands by 1,000,000 lines. So it simply becomes impossible to actually do this virtual map of the map where we expand outwards, because it's simply going to be too big. So instead I'm doing the exact same thing, where I'm finding these expand points by x, expand point by y, and should be worth mentioning, for both exercise 1 and 2, I'm using the simple Java object, just simply containing the x and y coordinates. I'm simply counting all the expansion points out to the left of us, because that's then gonna be added. We're only gonna be expanding if we are to the right of the expansion position. We then do it for both x and y, and we then simply just add a factor of whatever, which in this case is gonna be a factor of 1,000,000. So otherwise, everything's the exact same. We now have these galaxy points, and once again, we just simply use the Manhattan distance, which is simply calculated by taking the absolute value of x1 minus x2 plus the absolute value of y1 minus y2. So relatively simple, and at least to me, as soon as I realized we need to use the Manhattan distance, all of this become quite simple. And because in part 2, we're doing more or less the exact same thing, we're just adding a factor, the runtime is more or less the same. But that was my a bit shorter showcase today of the Advent of Code Day 11. If you enjoyed this showcase, please leave a like and subscribe, and I wish you all a wonderful day.